So we're going to start to talk about basic factoring. This is learning target 4. And here's kind of my little warning to you. My little warning to you was, do you remember when we did exponent properties? And I had this big talk with you at the beginning, and I said, listen, for about the next 2 weeks, I'm going to show you some learning targets, and each one will build off the next, right? And then we did the products, and then we did the quotients, and then we did the power. And those 3 were the basis for all the rest of those, right? With negatives, with zero exponents, all together. And can you imagine even trying to do these without knowing how to do these? Okay, no. The same thing is happening with this learning target that we're starting next. So I want you to take a peek at here. In polynomials, there are 8 learning targets. We just did like the baby warm-up stuff. Okay? We classified them, binomial, trinomial. We added and subtracted, and we even multiplied. But I want you to notice what word you see in every single learning target from here on out. Factor, factoring. Okay? Factoring is a huge part of algebra. You need to be able to factor, and same thing here. This is the basic factoring. Then I add another little step to it. Then we do some more special cases. Then we do the GCF. So it's all going to be based on what we're learning right now, which is learning target 4. So it's really important that you kind of stay with me and understand these rules with that, okay? So first of all, let's talk about what the word a factor means. What is a factor? Like in, 3rd grade. When I said, give me all the factors of 12, factors are the numbers you multiply together to get the product, right? So basically, here's how it goes. Factor times factor equals product, right? This is a side note, but do you know that's called an addend? An addend plus an addend is equal to a sum. So basically, the numbers you multiply together to get a product are called factors. So you remember doing this. 1 times 12 will give you 12. 2 times 6 will give you 12. And so will 3 times 4, right? So you just factored 12. Woo, fancy. We're going to do that on a bigger scale. Okay, so factoring means coming up with the 2 numbers, or in this case, the 2 binomials that you multiplied together to get that. So for example, I started you out with x plus 3, x plus 7, and gave you the factors and asked you to find the product, right? So you said you either use the box method or the double distribute, right? And you said x times x was x squared, x times 7 is 7x, then you had a 3x, and then you had a 21, and then I told you to look for like terms, and then you ended up combining these 2, and you said x squared plus 10x plus 21. Okay? So what you need to know is that these are the factors. The factors are x plus 3, x plus 7, and this big old trinomial is your product. Okay? That's all. So if I were to give you this today, which is factoring is the opposite of box method. It undoes box method and double distribute. I'm going to start you with this today and ask you what 2 binomials you multiplied to get that. So I'm going to say, x squared plus 13x plus 40. Which 2 binomials did you multiply to get that? So first thing, I'm not asking you to answer that. I just want you to know where we're going with this today. So we're factoring our answer, which is what we did right here. We factored 12, except that was really easy, right? Okay? So I will start you off with this. I will say that the first year, I was amazed that nobody of all 3 classes came up to me when we were doing our multiplying 2 binomials and said, can I just put an answer because I know already what it's going to be? Did anybody kind of, after doing a bunch of these, realize where 10 and 21 came from? Okay. Maybe you just knew that. Yes. So let's take a look at this. Let's do a little bit of let's take a plus 4, a plus 7. So whether you did box or double distribute, you got an answer. You said A and 4, A and 7. Gave you A squared, 7A, 4A, and 28. Right? And that answer was A squared plus 11A plus 28. Did anybody pick up on the fact that this step in this box, you probably could have skipped it? Okay? So how did you realize? So then how did you come up with 11? And how did you come up with 28? What would you know? Like if I did x plus 3, x plus 10, what do you think that answer would be? Without showing anywhere. X squared plus 13x plus 30. Good, okay? So you went right to x squared plus 13x plus 30. So right there is the perfect opportunity for me to say, okay, what? How did you get 13? What did you do with 3 and 10 to get 13? You added them. So 13 is called a sum, right? And then what did you do with 3 and 10 to get 30? You multiplied them. So 30 is going to be called our product. So keeping that in mind, when we go a little vice versa here and go backwards, and I start you with this, wouldn't it make sense for me to say, this is where I said it's going to be kind of like solving riddles. So if somebody were to walk up to you on the street and say, all right, give me two numbers that when you add them you get 13, but when you multiply them you get 40. Two numbers that when you multiply them you get 40, and when you add them you get 13. 5 and 8. Right? Isn't 8 times 5 40? Isn't 8 plus 5 13? So I just found my factors. Okay? Except there's a little bit of a twist to it because I still have to write here what did I do to get the x squared. And then I multiplied a positive 8 times a positive 5 to get positive 40. And here's how you check it. Is a positive 8 plus a positive 5 positive 13? Yeah. Okay, let's do another one. No, it does not. If your parentheses are reversed, if you have the x plus 5 here, totally fine. And the reason for that is because multiplication is commutative, right? And the order does not matter. So let's see how quick your brain can get these answers. Once you get it, like, you got it, and you'll fly. You'll come up with them quickly. So what two numbers did I multiply to get 18, but add to get 11? Just raise your hand if you think you know it. Don't shout it. Give everybody a minute to work through it. So what did you multiply to get 18, but add to get 11? What do you got, Anastasia? 9 and 2, right? So first, watch this, because I still did my x times my x to get my x squared. And then I did a positive 9 times a positive 2. Okay, so you probably already picked up on this, but which one is easier to start with? Finding all of the sums of 11 first or all the products of 18? Which one do you think is easier? The products are always easier because, shoot, I could do 1 plus 10, 2 plus 9, 3 plus 8. I mean, there's a lot of sums, right? And what if that was 30? Okay, so you would start with finding the products. 2 times 9, 3 times 6. I only have 3 pairs to look at. And sometimes you guys are probably good enough to do this in your head and find the sums or the products in your head. For some people who are just starting out, like maybe if this were taught, I used to teach this in 7th grade, I would have them write these out. And then I would have them look at them. Well, if I added those, I'd get 19. If I added those, there's my 11. If I added those, there's 9. So you know that 2 and 9 are your pairs, right? We don't need to do all that. You got it in your head. Good? Okay. So always start with the product first. I'll give you one more, and then we're going to move on to, because there are 2 other types of things that could happen. So ready? W squared plus 18W. Oh, this is not a good one. I won't have you try this one. I use this one as an example to say that, here's the deal. I'm looking at 56. And 9 times out of 10, the factors you need are going to be the ones that just pop up. Like, I don't know about you, when you see 56, don't you think 7 and 8? Or at least you should. Well, 7 plus 8 is not 18. So then you're kind of like, shoot, there's factors of 56 that I don't really know. So then at some point, you maybe have to do this. So 1 times 56. 2 times what? 28. 3 times nothing. You know how I know 3 doesn't go into 56? Because 5 plus 6 is 11. And 3 does not go into 11. 4 times 14. There you go. There's your 18, right? So I'm showing you this for a reason, because it's not always going to be up here in your head. You may have to go, oh shoot, now I got to go off to the side. So now this is going to be a W plus 4 and a W plus 14. Let me show you why. If you ever get confused, just double distribute it back out. W times 14 is 14W. And then there's your 4W. There's where your 18 is coming from. And here's where your 56 is coming from. Product, sum. Okay? You think you're good with that? Now go ahead and try this one on your own. Ready? N squared plus 10n plus 16. So you're thinking of 16. 4 and 4 would be 8. But 8 and 2 would be 10. So did you get n plus 2, n plus 8? Okay. All right, so that's the easy part, because I've been giving you 2 positives. We got to talk about negatives and how negatives is going to throw things off a little bit. Let's just do this one. A squared minus 17a, but a plus 72. Okay, so now let's stop and think about this for a minute. I know you want to try to go get the answer, but we have to kind of think about what this means here. So my product, is positive. But my sum is what? Okay, so here's what you do first. Ready? Whenever you factor, your eyes will go right here every time first. Because this little sign right here is the boss. It dictates everything. So if your product is positive, there's 2 ways to get a positive product, right? Either a positive times a positive or a negative times a negative, right? But if my sum is negative, what's the only way to get a negative sum with the signs being the same? If they're both negative, right? So I know, watch what I do, if this is positive, but my sum is negative, I know that both of those signs inside of my parentheses are going to be minus. I'm going to do it separate like that. So I do my signs first. I don't put my plus 4 plus 14. I'm going to show you what I mean in a minute. So I'm going to put my signs down first. I know because that's positive and that's negative, they both have to be negative. Okay? So now then, I just find out what 2 numbers, when I multiply them, give me 72, but when I add them, give me 17. 8, 9, right? And because my minus is already there, I have a negative 8 and a negative 9. And it doesn't matter the order you write them. Because they're both minuses, right? So watch. I tell kids every year, you can guarantee yourself a 100% on every factoring test you take. How? By checking it. Can I just box it out or distribute and see if I'm right? Right? A times A squared. Negative 8A, negative 9A. Oh, and there's where my plus 72 comes from because they were both minuses. And there's where my negative 17 came from. Do you see how easy it is to check your work? Okay? Almost everybody always gets 100% on every one learning target 4 on this test because it's easy. All right. So try this one then. Give you another one. k squared minus 13k plus 42. So I'm starting off with 42. I'm not thinking 2 times 21. I'm thinking 6 and 7. Those should be like your basic facts that you should always go to. If that doesn't work, then you have to get creative. But 6 and 7 works here, doesn't it? So my product is positive, but my sum is negative. So when this is a positive, I got to look next door. They're both negatives, right? And then it doesn't matter where I put the 6 and where I put the 7. Here's how you check it. What's negative 6 plus negative 7? That. What's negative 6 times negative 7? That. That's how you check it. That's kind of like, instead of showing your work, just doing it like that. Okay, there's one example we haven't done yet. And that's when my product is negative. So we have to kind of clear up what happens then. Because it's not as bad when your product is negative. It puts one little speed bump in things, but nothing that you won't be able to handle, okay? So like, let's say y squared plus 2y minus 15. All right. So I know I got y squared by doing y times y. Okay, and then that's where I'm going to stop. And then I'm going to look at my product, because that's what I said to do. Every time you factor, your eyes go here first. Okay, because that dictates what goes here, right? So it's kind of easy in a way, because there's only one way to get a negative product. By multiplying a positive times a negative, right? So look what I'm going to do. I'm not even going to worry about my numbers right now. I take care of my signs first. It's just the way I've always done it. So I'm going to put my plus and then my minus. Okay. Now, little change up here. If I start to list all the factors of 3 or 15, I don't see any that add up to 2. But do you see some that subtract to give you 2? See that right there? See how before it was a plus? That meant add your factors. This means subtract your factors. So I know I'm going to use 3 and 5. Now what's my next dilemma? Both of those signs aren't the same. Put where you think it should go and then box it out and see what. Because remember how I said, oh, put them anywhere because they're both pluses. One of them, and actually if you want to just think about it before you do it, it has to do with your sum, doesn't it? I'll give you a hint. Does negative 3 times 5 give you negative 15? Yes. Does positive 3 times negative 5 give you a negative 15? Yes. But only one of those pairs gives you a sum of positive 2. It's all about where you put the sign that you want it to be, and you can control that, right? So which one do you think needs to go here? The 5. Because when we subtract, we take the sign of the larger number. So put the larger factor with the sign that you need your sum to be. That was so important, I'm going to say it again. Okay? Put the sign of the number with the, or your number, with the sign that you want it to be, and then this one goes here. Did you have a question, Isaac? Yeah.
Oh, yeah. Well, the sum was negative, would it be like split?
Yes. Mm-hmm. If that was a negative 2, then I would have to put the 5 with the negative. Yes, absolutely. Okay? So it's easier in a sense because you know it's just one's going to be positive, one's going to be negative. Would it be wrong if you put the plus 3 minus 5? Yeah. Because, so I just kind of want to show you. This gives you that. So look, if I had y plus 5, y plus 3, y plus 5, minus 5, gosh, I can't get it right. I want to show you what would happen. You would have your y squared minus 5y plus 3y, you'd still have your negative 15, which would work out. But that wouldn't. You would have y squared minus 2y minus 15, and I don't want it to be a minus 2y. Do you see? Okay, so try this one. So r squared minus 2r minus 8. What is that beeping? So you're looking for two numbers that when you multiply them, you get 8, but subtract to get 2. And then you play around with your signs separate. Does it matter if you put the minus first? No, not. I just always instinctively put plus minus. So my pluses will always be first. Okay, so I don't really have that many choices. It's 1 and 8 or 4 and 2, right? Okay, so 4 and 2, both of those are going to give me negative 8 when I multiply them, but which one's going to give me a negative 2? So I look at the 4, and I need the 4 to be negative. Did you get that? Okay, try another one. This is always a good one. P squared minus P minus 42. And then try this one. So what is the coefficient you're looking for here? Negative 1. So I'm looking at this, and I see that this is a negative, so I know I multiplied a positive times a negative. 6 and 7 are going to be my numbers. I need a sum of negative 1, though, so the 7 has to go here and the 6 there. If you have these flip-flops, meaning if you have the P minus 7 and the P plus 6 over here, that's fine. You can't have it minus 6 plus 7. You know that, right? Okay? So same thing happens over here. 5 and 6, right? Except this time, I want my sum to be positive, so where should the 6 go? With the positive, and the 5 goes here. Okay, I think you got it? Okay, so let me just give you one little summary. All right? So let's say, here's your summary. I'm going to use a couple different, actually one different color here. So if I have... okay, this is the actual, go back up to your notes here. A equals 1. I'm going to do this. A squared plus, sorry, not A squared, X squared. X squared plus BX plus C. This is the form that they're talking about. C means your constant. B means your coefficient for whatever number's in front of your x term. So like here it was 13, here it was 11, okay? And x squared, that's your x or your y or your a or your b or whatever, okay? Okay, so that is this form. So watch what I do when I do this here. So do you guys got that? X squared plus bx plus c. Constant, x coefficient, and then the coefficient here is just 1. So do you see how I wrote in this basic factoring a equals 1? Because you know what tomorrow that's going to be? A 2 or a 7 or an 8. And all bets are off. Like Monday when we get into a coefficient, it's a game changer. Like this little rule that we've been using, we can't use anymore. So watch this. If I have x squared plus bx plus c. So when both of those are pluses, and this is, I don't want you to come up to me and say, what are the signs in the parentheses when one's a plus and one's a minus? No, that means that you're trying to memorize it and you're not thinking about it. I want you to look at it as your product is positive and your sum is positive. So you know that means that you have to have two positives, right? That's the only way to get a positive product and a positive sum, right? Okay, if you have x squared and then a plus here but a minus there, don't come up and memorize it. Say to yourself, well, my product is positive, so I know that both of the signs have to be the same. It's either going to be plus plus or minus minus. Well, to figure out what they are, look at your sum. The only way to get a negative sum by adding two that are the same signs is a negative plus a negative, right? So look, negative plus negative is negative, negative times negative is positive. This is a nightmare lesson for 7th graders who just learned their integer rules. Because they keep saying, I thought you said a negative and a negative is a positive. And I'll say, it is when you're multiplying, but they're trying to. Do you see how crazy it gets? But you guys are good on that, right? Okay, I hope so. So then the next and last thing is x squared. And then, watch what I'm going to put right here. I'm going to put does not matter. Doesn't matter what that sign is, so I'm not even going to put one. Why? Because if that product is negative, then you know what your signs are, right? It's a positive times a negative, or a negative times positive, whatever. Okay, I will need that sign, though, when placing my factors, right? Okay? Does this help you make sense? So please don't memorize this. Just think about it, and if you use a little bit of common sense, and you know your integer rules like you do, then you'll be fine.